Okay, so looking at the warm-up, we're just gonna see the coordinates of these points. And if you remember the last activity on AS07, we found the coordinates of this point right here. It was x equals 1, y equals 0, right? It's because the unit circle is a radius 1, so this point is 1, 2, 3, etc. This is 1, and then it goes up 0, so it's just 1, 0. So that was this point. We're going to find the rest of the extreme points on the unit circle, but that'll give us a hint to the rest of them, right? So A is at x equals 0. It's still at the origin, right? But you go straight up to y equals 1, right? Because up is y, so then that's going to be 0, 1. X equals 0, y equals 1. Coordinates for B are going to be, well, you go backwards this time, right? You go back 1, so x, and since it's over, it's the x value, right? So negative 1 is your x value. And then your y value is 0 because you don't go up at all. So once again, just like the one we did the other day, y is 0. And then for the last one, it looks like we're staying at the origin again, but we're going straight down. So it's down 1, but we go over 0. So there's negative 1. And that's how you do that one. So slide 3, in our last class, we found all of these points. We also found this one. And so now we're going to try and use some symmetry to figure out the rest of these. So remember, we found these using reference triangles, right? And if you look at these, actually let me colorize those. And we also found this other one on the left as like a little teaser, but as you can see, and I tried to highlight it using the same color, it's blue, but it's also the exact same triangle as this one that we had at 30 degrees. And in fact, and this is 150 degrees, right, which is a 30-degree reference angle from the x-axis. It's 150 is 30 degrees distance from 180, right? 180 minus 150 is 30, so this is a 30-degree angle as well. So I wanted you on this one to connect the reference triangles from the prior activity to this one. So now we're trying to find this red one and then this green one, right? Well, this red one, following that pattern, is probably exactly the same as this red one over here. So if this is a 45-degree angle and this is 180, then it's just going to be 180 minus 45, right? Which I don't actually think that will show up in here, but oh, well, yeah, 135. So that is 135. And then the next one is this green one. This is the exact same triangle as this green one, right? It's just flipped over, but it's the same angle, same shape. So that means it's going to have the same reference angle right here. And so if this is a 60-degree angle, then this is also a 60-degree angle. And if this is 180, 180 minus 60 is going to give us 120. So now finding the coordinates of those, well, I can see, I'm going to use black for this because this isn't strictly for any of them. Doing that, drawing that straight line across, I can see that the y values are the same on at A and then at this green triangle, right? The y values are exactly the same. And so the y value here is this square root of 3 over 2. So that's going to be square root of 3 over 2. And remember, it's not square root of 3 all in the same. This is not correct. It's got to be square root of 3 over 2 like that. And then if we're looking now for the x value, right? Well, if the hypotenuse is 1 and the y value is the same and the angle is the same, basically everything is going to be the same. The side lengths, all the angles. And you learned about that in geometry. There was like the angle, side angle, and the different ways of figuring out similar triangles. But we know basically because same hypotenuse, 60 degrees, that's enough to say that this is going to be the same triangle. So then the x value is going to be the same too. It's just going to be negative because we're going in the other direction, right? So we've got, instead of positive 1/2, it's going to be negative 1/2. And then for the red one, once again, we've got the exact same y value. So for my y coordinate, I'm just going to do square root of 2 over 2. And for my x coordinate, well, I think it's going to be the same story, right? We're reflecting it over the x-axis, so it's going to be negative square root of 2 over 2. I just took the x value here and made it negative. So now we're going to look at the third and fourth quadrant, and we're going to follow the same pattern that we started on the last one. So we saw in this last one that we were kind of just reflecting these ended up being the same reference triangles, but we're going to have the same thing here. This is going to be the same reference triangle as this one, and they're going to be the same as the reference triangles that were right here too. And if you'll remember, this was the 30-degree, it was the first triangle, right? The blue one, it was the 30-degree one, it was the 30 degrees is the same as pi over 6. So we can even look at that and just copy the points down for the coordinates. So for A, this is the third quadrant, so my x value is going to be negative and my y value is going to be negative. It's below the x-axis and it's to the left of the y-axis. So that's the negative direction for both x and y. You go down and you go left. So both are going to be negative. Let's start there. And then from there, we just need to figure out what the numbers are for that 30-degree triangle, right? Well, let's just look at this and we can get them. 30-degree triangle, x is root 3 over 2, y is 1/2. So then this should just be square root of 3 over 2 and 1/2. And let's see if that works. Bingo. All right, so this other one, for B, it looks like it is a positive x value, right? It's to the right of the y-axis, which means you're going up with your x numbers. And it's below the x-axis, which means it's a negative y value. You went down. So let's put the negative on our y value. X is going to be positive, but it's going to be the same points, right? It's still the same triangle. So, in fact, I'm just going to copy this. Make it real easy. And then just delete this negative sign. There we go. Same thing for this one, right? These are going to be the same as the red triangles on this slide. They are both about halfway between, they're exactly halfway between 180 and 270, between 270 and 360. So that makes them like 45-degree triangles, right? So if they're 45-degree triangles, that means they're both going to have the same x and y value, square root of 2 over 2, and then we just have to figure out which ones are negative and positive. And I'm going to put that down here. It's the same triangle, remember? Now we just need to figure out what's negative and what's positive. So this one is negative, negative, right? Third quadrant, negative x, negative y. And this one is going to be positive x and negative y. It goes to the right and it goes down. So positive x, negative y. There we go. Slide 6. Okay, continuing that pattern. This is going to be the same as that 60-degree triangle. And I matched the colors up to kind of give you a hint at that. 60 degrees or pi over 3, they're equivalent. This is going to be the same as that. So then we're going to just look, we got to figure out, well, we already know, we've done this twice now. This is negative, negative, and this is positive, negative. And I think you can even see this distance from here to here, that's about half, right? And I know one of them is half and one of them is square root of 3 over 2, but I can never remember which one. So the way I'm going to remember it is one of these is about halfway to the other one, and that's this one. So that's going to be 1/2. That's my x value. And then my y value, it's much closer to 1. Square root of 3 over 2 is like 0.7 something. It's 0.8 almost. It's going to be a lot closer to 1. So as you can see, this one's a lot closer to being 1, right? It's just an arrow's width from the edge of the circle. So square root of 3 over 2. Oops. And then I'm going to copy that so I don't have as much to write. But my x value on this one was positive, and that's all I got to do. All right. And so this is the unit circle. We've now found all these points. We just found the whole bottom half pretty quickly. We did the radians and degrees before. Knowing the signs for the quadrants are very helpful. As you can see here, I didn't have to think too hard about this. I knew that quadrant 3 is negative, negative. I knew that quadrant 2 is negative, positive, positive, positive over here in 1, and then positive, negative here. And I think our unit circle, it doesn't have that, but we can add it. It is in this page, the reminders from previous classes, but right here. But we'll probably add it to our unit circle. I like to have it right there in the unit circle, just like somewhere there as a reminder. So the SOHCAHTOA, so the idea here was that tangent is equal to sine over cosine. Or in other words, what we found when we were doing this activity in the last class was that sine over cosine, or sine is equal to y, and cosine is equal to x, because we had y over 1 and x over 1 because our hypotenuse is 1. So then sine equals cosine, or sine equals y and cosine equals x. So then if tangent is sine over cosine, then that just equals y over x. So if I'm trying to find the tangent at 0, let's look back at this unit circle. I've got my x value is 0 and my y value, or sorry, we're here. My x value is 1 and my y value is 0. So that means if tangent is y over x, it's just 0 divided by 1. 0 divided by 1 is 0. And then at pi over 6, my x value is the square root of 3 over 2, and my y value is 1/2, so it's going to be 1/2 divided by the square root of 3 over 2. You could either do 1 divided by the square root of 3. That's basically the 2's canceled out. 1 over 2 over square root of 3 over 2. The 2's canceled out, and you're left. I'll just show you. These cancel, and you get 1 over the square root of 3. The other way to write that is the square root of 3 over 3. Pi over 4 is, that's the halfway point, 45 degrees. It's going to be square root of 2 over square root of 2 over 2. So you're dividing something by itself, that gives you 1. And then pi over 3, it's just going to be the inverse of this one, right? It was, instead of 1/2 over root 3 over 2, it's root 3 over 2 over 1/2, which means you just flip whatever was on the top is now on the bottom, whatever was on the bottom is now on the top. So in other words, it's square root of 3 over 1, which is also just square root of 3. Oops. So for quadrant 2, pi over 2, this is an important one because when you look at it on here, y over x is going to be 1 divided by 0. You can't divide 1 by 0. You can't divide by anything by 0. And the hint was to type it into the Desmos calculator, because if you divide 1 by 0, you get undefined. And then 2 pi over 3, well, we can actually start getting a little more systematic about this. Pi over 3 is right here, right? 2 pi over 3 is right here. They're the same triangle. Remember, the same reference triangle. Looking at this one and this one, which means they're going to have the same sine, cosine, and tangent, except for the signs may change, positive, negative, right? So now we can get real systematic about it. So we're in quadrant 2. It's going to be the same tangent as pi over 3, which is square root of 3. But it's going to be negative because in quadrant 2, y is positive, but x is negative. And a negative and a positive is a negative. Positive is a positive is a positive. Negative and a positive is a negative. And a negative and a negative is a negative, or is a positive. So that means for first quadrant and third quadrant, our tangents are going to be positive. Because in third quadrant, you have a negative and a negative, which cancel out and gives you a positive. So for 3 pi over 4, that's, again, you have the same x and y values, so you end up getting 1, but it's one's positive and one's negative, so you get negative 1. As you can see, these are all negative, and this is going to be negative 2, but this is going to be negative 1 over the square root of 3. I just used process of elimination on this one because I know that these are the only 3 possible values. And then we're just going to keep going with the same triangles. Pi is going to be the same. It's negative or 0 divided by -1, which is just 0. 7 pi over 6 is going to be this triangle here. I guess 7 pi over 6 was this one. 7 pi over 6 is going to be this. It's, remember that 30-degree triangle or the pi over 6 triangle. So that would be what we saw on this slide as 1 over the square root of 3. And it's going to be positive because it's negative divided by negative, and those cancel out and give you a positive. And then all the ones with 4 in the denominator are just 1, and this one's positive 1 because it's in the third quadrant. And then this one must be the other one, which is square root of 3, also positive because it's in the third quadrant. And then the last one, quadrant 4, they're all going to be negative, except for that one. They're all going to be negative because they're in the, they have a positive x value and a negative y value. So now we just, except for this one's 3 pi over 2, which would be -1 divided by 0, which is undefined again. And we got that, remember, because here on this one, -1 is our y, 0 is our x, -1 divided by 0. So then 5 pi over 3, let's just look back here. Which ones are the, so it's going to be square root of 3. See, the ones that have 3 in the denominator, I'm always looking for patterns, and that's something you should do too. And then this one's going to be 1, and this one's going to be 1 over square root of 3. And that's it.